Space junk has become a growing concern as thousands of defunct satellites, spent rocket stages, and fragments of debris now crowd Earth's orbit. This congestion poses a significant threat, not only to active spacecraft, but also to commercial aviation. The dramatic possibility of debris falling from orbit and entering the atmosphere raises safety risks for flights, especially as the number of objects in space continues to rise. With each new launch, the chances of collisions and uncontrolled re-entries increase, making the issue of space junk more urgent than ever before. Space junk refers to the collection of human-made debris orbiting Earth, which no longer serves any useful purpose. This includes non-functional satellites, discarded rocket stages, and fragments created by collisions between objects in space. As the amount of debris increases, so does the risk of further collisions, which can generate even more hazardous fragments. Some of this debris eventually re-enters Earth's atmosphere, and while most pieces burn up, larger remnants can survive and pose risks to people and property on the ground. Managing space junk is crucial to ensure the safety and sustainability of future space activities. The risk of space debris impacting airplanes is on the rise, largely due to the dramatic increase in satellite launches and the growing population of objects in low Earth orbit. With thousands of new satellites and fragments being added each year, the statistical likelihood of debris re-entering Earth's atmosphere and crossing paths with aircraft has become more significant. While the probability of a direct hit remains low, the sheer volume of debris means that incidents are becoming less improbable over time. If such an event were to occur, the consequences could range from minor damage to catastrophic failure, posing serious safety concerns for aviation. This evolving threat underscores the need for improved tracking and mitigation strategies to safeguard both air travel and the broader public. Airplanes are particularly vulnerable to space debris due to the extreme speeds at which these fragments travel. Commercial aircraft are not engineered to withstand impacts from high-velocity objects originating from space, making even small debris potentially catastrophic. While the likelihood of such collisions is low, aviation safety planning must consider worst-case scenarios to ensure passenger and crew protection. This involves monitoring debris trajectories and implementing protocols for rare but serious threats. Ultimately, the unpredictable nature of space debris highlights the importance of ongoing vigilance in aviation safety strategies. There have been several notable incidents where uncontrolled rocket re-entries have caused significant disruptions to air travel. For example, in May 2021, the re-entry of a Chinese Long March 5B rocket prompted authorities in several countries to temporarily close airspace and reroute flights as a precaution. Similar events have occurred in the past, with airlines and airports forced to adjust schedules due to uncertainty about debris trajectories. These disruptions highlight the limitations of current prediction and management systems, underscoring the need for more reliable tracking and coordination to ensure public safety and minimize impact on global transportation. Predicting the landing sites of space debris presents significant challenges due to the unpredictable nature of atmospheric conditions. Factors such as wind patterns, air density, and temperature fluctuations can dramatically alter the descent path of falling objects. As a result, authorities often face uncertainty regarding the exact location where debris might impact. To ensure public safety, large regions of airspace are frequently closed as a precaution, sometimes covering thousands of square kilometers. This approach helps minimize risk, but it also highlights the complexities and limitations involved in forecasting debris re-entry. Experts suggest several strategies to minimize the risks associated with space debris. Controlled re-entries are recommended, allowing satellites and rocket stages to be guided safely back into Earth's atmosphere, where they can burn up over uninhabited areas like oceans. Enhanced tracking systems enable better monitoring of debris, improving predictions and response times. Stronger international coordination is also vital, ensuring that countries work together to establish and enforce guidelines for debris management. Additionally, engineering solutions, such as designing spacecraft to disintegrate upon re-entry or targeting specific safe zones, further help to ensure that any remaining debris poses minimal threat to people and property.